In this video, we're going to make a very nice field of view effect. The view cone will start from the player and point towards the mouse while hitting any objects it finds. Everything outside the view cone is hidden. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so this is what we want to create. Over here I'm controlling my player moving around, and as you can see, a very nice view cone pointing towards the mouse position. You can see it interact with the object, so there's a wall in there and I cannot see behind that wall. And I can right click in order to make it see further or shorter. As you can see, it modifies both the view distance and also the field of view. Over here you can see a bunch of enemies, and as you see, they are only visible when inside the field of view. So if a wall is blocking them, I cannot see them. Using this with a completely black outside makes for a very interesting effect. So as you can see how this would be very useful for any kind of stealth or horror or strategy game. You can see this effect in action in my very first Unity game, Survivor Squad. The whole idea behind that game and its sequel was to control a team of survivors and very carefully manage where each was pointing in order to make sure that your survivors cover all the corners. So the field of view was a crucial mechanic, and I still really like those games because of it. The game is included in the game bundle, so go pick it up and play it to see how you can apply this effect to your own games. Also, this particular effect can be used to showcase enemy view cones, like in a game like Commandos or Desperados, and that's exactly what we're going to be doing in the next video, so stay tuned for that. But in here, let's start off very simple and make this nice field of view effect that works as a mask and interacts with walls and enemies. Alright, so this is our goal, let's get to it. Okay, so here is our starting scene. I'm controlling the player character with the keyboard, and I can use the mouse in order to aim and shoot. There are also enemies I can spawn and shoot and kill them, just like that. Okay. Now we're going to do a whole bunch of raycasts and generate a mesh based on where those raycasts hit. So let's begin by making our field of view script. Over here in our project files, make a new C# script. Let's call it our field of view. Now let's make a field of view game object and drag the script onto it. Alright, so now in here, let's first spawn a very simple mesh. If you want an in-depth video on how to make a custom mesh through code, check the video linked in the description. That video covers everything you need to know about how mesh is set up. So here I will assume you know the basics. So let's start off by creating our local arrays. Okay, that's the basic code. Again, if you're not familiar with meshes, go check out the other video where you will understand what all of these arrays do. Now in order to display our mesh, we need to go into our game object. And in here we also need to add a mesh filter to hold our mesh and a mesh renderer to render our mesh. Okay, so then here we just get the component of type mesh filter and set the mesh to our mesh. Alright, that should do it. Let's see. And yep, there's our nice simple triangle. Okay, so far so good. Alright, now let's try to make a triangle, but using our FOV values. Okay, so in here, let's define a float for our FOV. So we're going to set our field of view to, let's say, 90 degrees. Then we need to define the number of rays we're going to do, so an int for the ray count. And let's say we're only going to spawn 2 rays. The more rays we have, the more defined our field of view will be. However, it's also expensive to do a lot of rays, so we need to manage this carefully. For now, 2 will do. And then we need to store a current angle, which we're going to increase in our cycle, so a float for our current angle. And then we need to calculate how much we're going to increase our angle per each cycle in our loop. So a float, let's call it angle increase, and it's essentially our field of view divided by our number of rays. Okay, now we also need a view distance, so a float for the view distance. And that's pretty much all the values we need. So now that we have all our values, let's set up our arrays. Now in here, for our vertices, we're essentially going to start at the origin, so that's 1 vertex. Then we're going to have 2 rays, so that's 2 more. And our ray count will not be including the 0 ray. So we're going to have the ray count plus 1 for the origin and plus 1 for the ray 0. So in this case, with two rays going for a field of view of 90 degrees, we're going to have one ray firing at 0 angles, then one at 45 and one at 90. So that essentially makes 3 vertices plus 1 on the origin. Alright, now for the UV, we're going to use the exact same thing, so we can use vertices.length, okay? And now for the triangles, we're essentially going to have as many triangles as we have rays. However, for each polygon triangle, we have 3 values in here, so we do ray count multiplied by 3. Alright, this is the size of our rays. Now in here, let's first set our origin. So the vertices on index 0 is going to be our origin. So let's actually also go up here and define a vector 3 for our origin. And let's start off at vector 3.0, okay. So there's our origin. Now let's make a nice 4. We're going to cycle through all our rays. And now in here, let's place our vertex in the correct position. So we define a vector 3 for our vertex. And essentially we're going to place it on the origin. And then we want to move it towards our current angle. So for that, I'm going to use a function from the utilities. As always, you can download the utilities for free from unitycodemonkey.com. And here in the utilities, there is this nice function which converts an angle into a vector 3. So if you want, you can just write this yourself in your script. So in here, we call that function, we pass in the current angle, and we multiply it by the view distance. Alright, so that's the correct location for this particular vertex. Now we need to place it on our vertices array, so that means we also need to know the index. So in here, let's define an int for the vertex index. And we're going to start on index 1, since index 0 will be the origin. So here we set the vertices on that index to be this vertex. Okay, that's our vertex position. Then we need to increase our angle by our angle increase so that it increases for the next cycle. However, here actually when you increase an angle in Unity, you are going counterclockwise, when in reality here we want to go clockwise, so instead of increasing, let's decrease. Clockwise or counterclockwise is very important in order to make our triangles, which is what we're going to do right now. So here we need to set up the current triangles. So we also need an int for the triangle index. In this case, we start off at 0. And then here we're going to set the triangles on our triangle index. And first we set on the triangle index plus 0. So on the actual index, we're going to start off every triangle on the origin. So we start off on vertex 0. Then for the triangles 1 and 2, the 1 will go to the previous one, so our vertex index minus 1, and the 2 will connect to this one, vertex index. Yep, exactly like that. Okay, so this might seem confusing, but it all makes sense when you see it in action. And here, after we set all of our triangles, we need to make sure to increase our triangle index, and in this case, we increase it by 3. So here, every triangle will be from the origin to the previous vertex to the current vertex, and that makes a polygon triangle. However, in here, since we were connecting to the previous one, you can already guess that we might have an issue here. And the issue is this will cause an error if run on the first ray, since the first ray doesn't have a previous vertex to connect into. So we're going to make sure that we only run this if the I is bigger than 0. And then we also need to increase our vertex index. Alright, that should do it. Over here we have all of our fields that make this extremely easy to modify. So we can modify the field of view, the origin, how many rays we have, our starting angle, and the view distance. Over here we set up our vertices, UVs, and triangles. We cycle through all of our rays, we locate them on the correct position, we generate the triangles, and we move on to the next angle for the next cycle. Once everything is done, we simply upload it to the mesh. Alright, let's test, and we should be able to see exactly 2 triangles that put together make up a 90-degree angle. Let's see. And if there it is, and exactly as intended, we have 2 rays plus the origin ray. So here is ray 0, then ray 1, and ray 2. And if we pause, we can actually look at the wireframe. So here we are in the scene view, go all the way up here, select wireframe, and there it is. You can see exactly how the field of view is being generated. So over here is our origin. This is vertex 0, vertex 1, vertex 2. Then the first triangle connects this one to this one to this one, so it makes a triangle. And the second one connects this one, this one, this one, makes another triangle. Right, awesome. So right now this looks more like a triangle rather than a field of view. So let's increase the ray count to smooth out the rotation here. So in here, let's go into our ray count, and instead of just 2 rays, let's try to have 50. Okay, let's see. And yep, there it is. Our field of view mesh is now a lot more detailed. So you can now see very nice round. And if we stop and look at the wireframe, and there it is, you can see exactly how each triangle is set up in order to make our overall shape. All right, awesome. Okay, so here we have our very simple base. Now, as you can see, if we run the game, you can see a pretty obvious issue, which is the field view is not colliding with the wall here. So let's add object interaction. And also in order to see, I just added a material to make it half transparent so we can clearly see that over here our field of view is going past our object. Okay, let's deal with that. So back in our code here, over here we are simply placing the vertex exactly on the position. However, instead of doing that, we want to do a raycast. So we're going to do a physics 2D and call raycast. Now we're going to raycast from an origin, so it's this origin. Then towards a direction, so it's this direction. And then towards a certain distance, which is our view distance. Okay, so this whole thing returns a raycast hit 2D. And using that, we can test if the raycast hit 2D, if the collider is null. If the collider is null, then we did not hit anything, so we can run this code in here. So if we don't hit anything, we set the vertex to exactly where it was on the maximum distance. However, if we did hit something, let's place it exactly on the point where it was hit. And for that, the raycast hit actually contains the exact point. So raycast hit point, and that's our vertex. All right, it's that simple, and this should be working. Let's test. And if there it is, you can now see that it is colliding with that object. So if we pause and look at it, yep, there's our nice shape. It goes through there and then it hits that one, so it cuts off and then it goes past. Okay, awesome. Now in here, instead of creating our field of view just on start, let's do it on update so it constantly refreshes. So over here on start, let's simply set up our mesh and set the mesh filter, okay? And then we make a private void update. Okay, so there it is, very simple. On start, we create the mesh, we set it on the mesh filter, and then on update, on every update, we are constantly doing our rays. So now with the game running, I can now go into the scene, I can move it, and there you go, you can see how the field of view is changing. However, here, if we spawn an enemy, you can see a big issue that we have, which is the enemy goes in, and there you go, the enemy is now blocking our field of view. The reason is because our raycasts are colliding with everything. So it's colliding with the objects, but also with our enemies. So we want to make sure we only collide with certain objects. So for that, we're going to use a layer mask. If you want to know more about layers, layer masks, and bitmasks, check the video linked in the description. Here, we're just going to use it and select only the object's layer. So here I make a serialized field for a layer mask. And then down here on our raycast, simply use this layer mask. Just like that. And I can go back into the editor. And here on the field of view, you can see the layer mask, and here it's very nice and we can simply select. So in this case, I want the wall, which are all on the object's layer. So selected, and now let's test. And there you go, the field of view is now still hitting the wall, but it's going past the enemy. So here I can move the enemy around on top of the field of view and it no longer collides with it. All right, awesome. Now, so far, we've been testing our field of view being completely static in that position in order to keep things simple, but obviously the field of view is meant to be attached to the player and looking at the mouse position. So let's do that now. For that, let's go here into our field of view script, and we're going to make two functions. So down here, we'll make a public void. Let's make one to set the origin and one to set the aim direction. Okay, so here for the origin, it's very simple. We simply set it, and then down here we use it as we were doing previously. And down here for the set aim direction, with the given aim direction, we need to calculate our starting angle. So we calculate our starting angle to be our aim direction. So we need to convert a vector 3 into an angle. So again, there's a nice helper function on the utilities. Here it is if you want to make it yourself. It just takes a vector 3 and returns a float for our Euler angles. So we take that, we pass in the aim direction. And if we do this, the starting angle will be exactly on the aim direction, whereas we want it to be on the middle, so we simply subtract our current FOV divide by 2f. So let's also put the FOV all the way up here. Alright, so that's it. Here we set the starting angle, and over here on our update we use it. Okay, so these are our two functions. Now we need to call them, so let's go into our player class. Here is the player class. Now how this is implemented is irrelevant for the field of view. All we care about is to use the player position and the aim direction. So in order to call that on the field of view, we're going to add a serialized field in here for our field of view script. And here is the update code. So here we have our aim direction. So it's in here that I'm going to call the field of view, set the aim direction to this aim direction. And then also go into the field of view and call set origin and pass in the transform.position. Alright, so that's it. Again, all of the other implementation doesn't matter. All we need to do is call these two functions. And since we're doing this on update, let's go here into our field of view, and instead of running this on update, let's do it on late update. So first the player sets the origin, sets the angle, and then on the late update, this one generates the mesh. So finally, we just need to drag the field of view reference like that. Okay, let's test. And yep, there it is. You can already see the field of view following the player and looking at where the player is aiming. And everything is still working, so if I go towards this, yep, there you go. As you can see, it is interacting with the object, and that one right there, and down here, all of these ones, and yep, it's working all perfectly correctly, and it doesn't hit the enemy. Alright, awesome. Now our code is set up in a very nice way to easily modify the various FOV parameters. So let's play around these values. Over here, let's try putting the FOV just at 40, and let's increase the view distance to, let's say, 80. And yep, there it is. Our field of view is now much tighter and it goes for much further. So you can see just how easy it is to play around with these values. So let's make it so that the player can easily swap between various FOVs. So for that, we just need to also add functions in here in order to be able to set both of these, both the FOV and the view distance. Alright, there it is. Very simple. We just have two more public functions. Okay, so here it is, very simple, adding some button press on the right mouse button in order to toggle a short and long. Let's see. Okay, here we are, and yep, I start with a normal field of view. Now I right click, and yep, there it is. The field of view is now much tighter, but also longer. So click again, back to this one, click, and back to this one. So this is kind of simulating as if you were aiming down sights. So like this, you can see further, and like this, you can see wider. Here is the code, extremely simple. When we click on the right mouse button, simply flip a boolean, and we set the FOV and the view distance. So you can see how easy this class is to use. And here it is again, swapping between both things. Right, awesome. Okay, so now all that's left is to apply our visibility effect. We want the enemy to only be visible when inside the field of view and invisible outside of it. In order to achieve that effect, I'm going to use the scriptable render pipeline. So over here I have a lightweight render pipeline asset. And as you can see, it has a custom forward render data, so we can see that. And here we have three render features. So the default layer mask will render everything except the things on the layer mask, the behind the mask, and the black layer. So let's see how those are used. Over here you can see the walls are on the objects, as you saw with the Raycast. And over here the enemy prefab is on the behind mask layer. And our field of view, let's put it on the mask layer. Over here I'm using a custom material that doesn't really do anything, it's just so I can easily modify the alpha. So here, back in our renderer, again, the default layer mask is printing everything except the mask, behind the mask, and the black layer. And here on the mask, and on the behind the mask, here you can see all we're doing is messing around with the stencil. So first the mask renders to the stencil buffer, and we write with a certain value always. And then on the behind the mask, we're only going to render where this previous value was rendered. So if we run the code, we can see, okay, here it is, I'm pointing upwards and the enemy down there is not visible. And if I go there, yep, there you go, the enemy is being visible. All right, so everything is working exactly as a mask. So we create our mesh, and the mesh works as a mask. And if inside the mask, the enemy is visible, if outside, he's invisible. And now instead of having the world like this, as you saw, there was another black layer. Let's see that one. That one is in here on the main camera. I simply have a game object occupying the entire camera. and this one is on the black layer. And back on the custom forward render data, you can see the black in there. This one essentially does the opposite of the behind the mask. So it only renders this one where the mask is not visible. So if we run this, there you go, everything is black except on the field of view. And again, let's get rid of the alpha on our field of view mesh. So here it is with 0 alpha, you can now see our actual field of view effect. So again, I right click and I can change the shape, and there you go, just like that, everything looks nice. And the enemy is right there, but he's hidden, and now I go, and yep, I can see him now. All right, awesome. Now the player like this looks a bit weird, so let's make sure that he's always visible. So for that, I can simply go over here into the character and simply spawn, let's say, a sphere. So there it is with the sphere, make sure that it's on the mask layer. And yep, there's the sphere. As you can see, it cuts a hole on the black sprite. And yep, there it is. So now I can see the player and I can see all the enemies only when inside the field of view. And now with the entire world black, you can see that this looks very interesting. So just like this, you can imagine some sort of stealth or horror game. And now with the enemies being spawned, I can go move around constantly looking. There's one there. Now, yep, there's another one there. And another one, and yep, there's one there, right there, hiding behind the box. And yep, there you go. Now here we have one final issue to take care of. There it is, our field of view is working nice, nice, nice. Go down, and yep, there you go, now it's invisible. The reason for that is our render bounds. Essentially, our field of view is trying to render a triangle in here, but the origin of the field of view game object is all the way up there, so once it goes past a certain area, as you can see, it goes to here, and it stops being visible. So let's solve that. All we need to do is down here, when we assign the mesh, we go into the mesh and set the bounds. Here, just a very large bound will do enough. So let's try. Okay, so here we are. Let's go all the way down here and see if the field of view disappears, and it doesn't. So now we can play around for the entirety of our map. And there you go. Now I put the outside mask in a pure black, and you can see that right now we have a very nice, very interesting, like a stealth or horror game effect. So there it is, all those enemies are being spawned, and I shoot them, and they are invisible if they are outside of my field of view. So here we have our final field of view effect. It is easily customizable, so we can modify all the parameters like the field of view, number of rays, view distance, and so on. So here, for example, by clicking, you can see me swap between a field of view that is wider but a short distance, or a tighter field of view but goes for a long distance. So this is simulating a very nice aim down sights effect. If you want to see this effect used in a complete game, then check out my Survivor Squad games included in the game bundle. Those games are all about controlling your survivors and managing each field of view to make sure you cover all corners. Personally, I really enjoy it, and Survivor Squad Gauntlets is definitely one of my favorite games. So go play it to see how you can apply this effect to your own games. Also, this particular effect can be used to showcase enemy view cones, like in a game like Commandos or Desperados, and that's exactly what we're going to do in the next video, so stay tuned for that. As always, you can download the project files and utilities from unitycodemonkey.com. Subscribe to the channel for more Unity tutorials, post any questions you have in the comments, and I'll see you next time.